we are. What's the date today? March 14th, Pi Day. I'm wearing my shirt. Okay, well, actually, this shirt has a story, if anyone cares. So, if you notice on the back, I have three digits. Anyone know what those three digits are? They're part of the number pi. When I was at Wheaton North, um, we actually had Pi Day be an actual day of math, and our whole math wing, we had a bunch of math things going on. Like one thing I remember, we had a jar full of, I believe it was marbles, and people had to guess how many marbles were in the jar. The people that won the contest actually did a volume thing. I think the jar was like kind of like a cylinder and then ended with a cone or something like that. It was some kind of multifaceted figure, and they figured out the volume of that and surmised the volume of each marble, and then just through those two comparisons came up with the closest guess. I forgot what they won. I think we had gift certificates for area stuff and blah blah blah. Well, all the math teachers wore this shirt, and all the math teachers had three digits of pi on their shirt. Mr. Samide, who I've mentioned, I believe, in here before, that's the guy that would, these whiteboards that someone wrote a book about that students should all be up. Mr. Samide did this 30 years ago. He always had his students up on the board. That's why on my door right now I have that thing because I used to do it with those little posters all around my room. So he was 3.14. He was the most respected guy in our department. Next guy was Mr. Crowell. He was the next three digits. Then all the rest of our teachers had digits of pi on our back. We had like 20 some teachers, so that's about 60 digits. At the end of the day, we had a math. What do they call it? Because they don't do these anymore because they're illegal. Assembly. You ever have an assembly in a school? Do you ever have an assembly? We used to have assemblies when we would win state. Like we'd all go down to the school and rah rah rah, cheerleaders, would perform and blah. But anyway, we had literally had a math assembly. And the last thing, one thing they got to do was elect a teacher to get a pie in their face. Anyone know who got elected? I did. And then and then at the end, the very last thing they did is they had to organize the teachers in the correct order for the digits to be in the correct order of pi. So it's actually a really cool day. I always like thinking about that day wearing this shirt. Uh, so anyway, gosh, what was that like 2000? Probably had to be around 2003, 2004. So we're talking about 20 years ago. So anyway, good memories. La la la. I wasn't even going to tell that story, but I just thought about it, seeing my fat face in the window here, and then seeing my shirts. Okay, all right. Here's how we're supposed to think. I know we didn't do these, and I AP. We were doing sine, cosine, and tangent of the unit circle. We should have mentioned these other three while we were doing it. I did when we did degrees first, but then it just was focused on sine, cosine, tan, I believe, with you guys. Could be wrong. I am two honors, did the same thing right around the same time. We had like an overlap, whereas teaching the same thing between my five classes. But here's how you got to think. Who's secant related to? Secant's related to who? Cosine. So what's the cosine of an over 3? Half. Flip it. That's 2. What's cosine in quadrant 4 or 3, though? Positive or negative? Negative. Boom shakalaka. Okay, cosec. Well, 3 pi over 2. I always like doing this. I always do my fallback because it takes me 3 seconds to write that coordinate down just to analyze this correctly. Cosecant's related to sine. Sine is the y coordinate. Flip -1, you get -1. Cotan of over 3. I know a tan of an over 3 is root 3. I got that down. Tan of an over 3, root 3. All right, so cotan is root 3 over 3, the flip of that. I don't know. You got to get some sort of tricks and get these ratios memorized. I see some of you writing them down as I write them. These are the ones that are totally and severely behind. You need to have something down and figure this stuff out. Secant of an over 6. Sine of an over 6 is a half. So secant's root 3 over 2. And cosine is negative in quadrant 2 because that's close to 6 pi over 6, but you jump backwards. All right? 7 pi over 4, come on. Cotan and tan of over 4s are 1. Those are 45s. Quadrant 4. Did I do something wrong? What did I do? Oh, you're right. I didn't flip. Right, right, right. Thanks. 2 hands went up. Awesome. 2 root 3 over 3. My bad, dogs. Let's talk about cosine. I forgot to do the flip for the reciprocal. All right, 5 pi over 2 is 3 pi over 2. I'm sorry, that's stupid. 4 pi over 2 plus pi over 2. 4 pi over 2 is 2 pi. So I'm up there. I don't have to draw the chord. I like drawing it just to think about it. I don't have to write it. I know it's 0, comma 1. Secant or cosine of that is 0, so the flip of that is undefined. So secant is undefined there. 0, comma 1, cosine, comma sine, cosine 0, flip. Right? Last but not least, this is in quadrant 3 because negative 6 pi over 6. And then, well, tan of an over 6 is root 3 over 3. So this one is root 3. All right? That's what happens with cotan and tan of 30s and 60s, or over 6s and over 3s. I wanted to do that respectively. And it's in quadrant 3, so it's positive. I saw some of you write every single one of those as I wrote them. Yeah. Okay. Again, we got to get there and understand, what's happening there. That's all fine and great, that chart over there. I'm going to actually look at this graph to graph cosecant. What's cosecant? The FLA. Anyone FLA? Flip. Okay, and you can see in the chart that this actually happens, and this actually tells you how you're going to graph cosecant. You are literally going to graph sine, and then you're going to anyone? Flip. But the thing you need to know is the zeros flip. What's the flip of 0? Starts with the U. Undefined. So for cosecant, we're going to put our asymptotes where there are zeros. Okay, now remember when you when you shift up or down, the zeros shift, but that's still where the undefined values will be. So, and then actually, I don't want you to draw a sine as a full solid line. I want you to also dot that line, right? Because that is not part of the graph. But this is just introductory. So we're establishing a concept. Right. And, I guess it's not bad to remind you of sine. Remember the two bowls, period is 2 pi, not pi. So we got to separate tangent and cotangent from, because that's the most recent thing we've done. Hey, and then what's the flip of 1? What's 1 flipped? 1. Now, the other thing they do is they have root 2 over 2 up there, which is 0.7. You could go ahead and approximately go on your calculator and take 1 divided by 0.7 if you care. Or you could just watch me and say, hey, 1 divided by 0.7 is actually symmetric with this. It's like somewhere up there. It flips it up there. What I really want you to understand is the flip of very, 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 very small. The flip of that number right there. Let's pretend it's 1/10. What's the flip of 1/10? 10. So this flips way up here. This is why we have an asymptote, because that's the behavior of the graph. Right when we get to that undefined value, right before that for sine, these numbers are infinitely small. The flip of infinitely small is infinitely large. And that should be a concept we understand at this point. Same thing with this. When I flip this, this is way up here. So you have what looks kind of like a parabola, although it's not, because it's controlled by asymptotes. Parabolas are not controlled by asymptotes. All right, and then you should get the gist. I don't even have to look at pi over 4 or over 4 values. I have to look at this. This is like negative 1/10, so this flips to way down here. And then that's what you have over here. Say hello to your cosecant graph. The students are waving. All right. So you take these high and low points, and they're shared by both graphs no matter what. And then you flip all the other ones. So it's like these U's that go up and down. And you'll see cosecant wrong. Secant is almost identical in how you do it, except, cosine just a little shifted. So secant graph will be a little shifted compared to that. Okay. Domain and range. The domain of sine is all real numbers. The range is negative 1 to 1 since we're not stretched or shifted. There is an amplitude. The amplitude is said to be 1 of this, and the period is 2 pi. All right, and then notice the equation of all the x-intercepts. We will write that because it's the equation of all the vertical asymptotes for cosecant. So it's really the same thing. And our x-intercepts start at 0 and the next one's at pi. So the equation of all the x-intercepts, I guess we say x equals, this is where they're located, is pi n, half of the period, all right? Because they do, you have a bowl up and then a bowl down, right? So there's a 0 in between the period there. So that's what's going on there. All right, I don't know how we want to word this. I guess I'll be lenient because it's one way or the other. The domain is a not equal to sign. The asymptotes is an equal to sign. So I don't like this terminology here. So let's cross this off and just say this is the equation of all the asymptotes. And then I got to talk with the crew on our test, the wording of this. You see, they're just asymptotes or domain. One or the other, they're not the same notation. So for asymptotes, it is an equation. It's x equals, and it's that pi n. It's the flip of those zeros. Remember, if I plug in 0, I get x equals 0. If I plug in 1, I get x equals pi. All right? And then let's do our thing where n is an element of integers. Ruh-roh. Okay, the range, and that is oh, yeah, I thought it was just a student walking in. I am taping. Can you, sorry, I'm tethered to the thing here. No, he gone. He ain't here. Yeah. All right. Yeah, it was. All right. Um, okay. So so that is the domain also. If it was domain, it'd be this. Yoink. Okay, and that's the point. It's one or the other, right? And we got that. That's really true. I'm not wrong. And then look at the range. The range is odd. The range isn't from 1 to -1. It's everything else but that, right? Right, 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 right. Can someone shake their head, please? I'm not stuck. I'm just looking at kids who are like this. All right. Anyway, so the range is from negative infinity to -1, right? Right? Don't make me do it again. Union with 1 to infinity. That's supposed to be a bracket. I'm kind of like probably writing on too small of a page. I should zoom in there. Hey, and what's the period? Is this U the same as that U? Yes or no? No, but that U is the same as that U, right? So what's the period still? Still 2 pi. Is there an amplitude? Is there a high low point? No. I know there's stuff in between, but amplitude means it's cut. It's limited to a high and a low point. These go off to infinity and negative infinity. Rah, that's a big yawn. Okay, shaking off the cobwebs. Okay, so I'm just going to get into the graphing right after that, after we talk about secant as well. Cosine's minorly different. Secant's minorly different. What happens at the zeros? What do we put at the zeros? Asymptotes. Try to go faster than I do. Try to get your picture. All right. And it shows in the chart. I'm not skipping over the chart, but you know what? I feel like sometimes I just go, I want to stamp. I really want to get this done. I feel like teaching all period, like for the last 3 days, we got to get a break from that. All right. And then give you a chance to actually maybe do some homework. I haven't felt like that's happened in a while. Don't always have to be up at the board doing stuff at your desk after a lesson is the solidifying thing. All right. Okay, so I will say this. What's the rules of graphing secant, cosecant? You literally graph sine and cosine first, but we really should not make it a solid line because it's not the graph. We use it, I do it as a dotted, and I'll show you that. Then flip. I mean, it really is it. Get your asymptotes, flip, and you're done. It's one extra step. If you know how to graph sine and cosine, you have one extra step, and you'll be able to graph secant, cosecant. All the things that you did with sine and cosine, this is like review. This is why we used to do sine cosine graphs quiz, and then right after that we do secant and cosecant. Then I do cotan and tan because they're so different. AP, we're just following their pattern here. Okay, so sine and cosine again have a domain of all real numbers and a range of -1 to 1. Same, amplitude is 1, period is 2 pi. This case, the x-intercepts are shifted a little bit. The first one's at pi over 2, and then they still are pi n away. Let's do our NEZ. Did I do NEZ for Oh, yeah, I did for cosecant. I didn't up there, though. Nice. Nope, not plus. Got to write it a million times. If you still don't know what NEZ is equal to, you're on Jupiter. All right? It's an element of integers. I can plug in those integers and have that happen. All right. Let's cross this off. It just what are the equation of the asymptotes? And they are x equals the equation that sets up all those zeros. It's the same. Of course, we might shift right left. We're not doing that today. Shifting right left can be pretty tough. The range is the same as the range for cosecant. Yeah. Right. Period. None. Okay. We do like these for multiple choice things. What's wrong? What's wrong? Without a pass. It's Lockport. It's Lockport. There's no consequences. You could punch someone in the face. I didn't mean to do it. Okay, just go on to class. No consequences. No consequences. None. Zero. I'm going to try that. I was kidding. Don't try that. All right. All right. Okay, so here we go. What are the rules? You graph. Who do we graph for secant? Sine or cosine? Who do we graph? Sine or cosine? Cosine, and then flip. And then get your asymptotes. Probably get your asymptotes and then flip. So we do have, and we're starting to not like this 2 pi to negative 2 pi, but we'll do that. I think my next ones are the regular graph. Hey, by the way, go to this is why I did this on your, now this is the big page, right? I did that on purpose so we can graph really large. All right. And then the third page is like those AP, like multiple choice questions. I still wanted to save a piece of paper. So, um, so you're on the big page now. All right. Good decision, right? Smart. I may not even do that one graph on the third page because enough is enough. All right, so what's the period? What's the period when this is just x here? What's the period? Don't say 1, it's what? It's 2 pi over 1, which is pi. Or 2 pi, sorry. Yeah. Okay, there is a 1 there. I just wanted to denote that there is a 1 there. All right. Now, just to mention some things, this is A, but it's not amplitude. That just means for the cosine graph, you're going to go 3 high, 3 low. No big deal. All right. And then order of operations are still going to work. And I will do a little input. Say it. I will do input output. Y2 is where the asymptotes are going to be located. All right. Because you're still undefined there. The fatter Mac, you might want to do this. Remember for cosine, we would do this. We'd put our new x-axis there. That's where the zeros do, because you do get zero out of an evaluation for cosine there. But then you add 2, all right? But you get 0 first because of order of operations, whatever. Okay, how does cosine start? Does cosine start high, middle, or low? What's the first point? Cosine kid, so where does it start? High. So 2 plus 3 is 5. Hopefully you understand that. Okay, so I'm 3 above because of that value there. And then the period's 2 pi, so you end high. In the middle, you end low, or you're at the low point. So there's our shape happening for the cosine kid. The period's 2 pi, so we're all good here. Then these are the zeros. Just want to make sure I'm symmetric here. Yep. All right, and then I can flip over to the other side and continue the pattern. Watch. You many of you may not have to draw a cosine. These dots might be enough. But just so you know, I'm going to dot this because this is not the graph. This helps me create the graph. And I'm going to bore you with 2 order of operations input outputs. Number 1, why do we still have an asymptote at pi over 2? Listen. What's the secant of pi over 2? Hold on. What's the cosine of pi over 2? What's the cosine of pi over 2? 0. What's the secant of pi over 2? Say it. What's undefined times 3 plus 2? Still what? Undefined. So it's you got to get that dotted line. These are still the undefined values. Then I do want to tell you one more thing. This is why input, say it, output. I'm going to do this so you understand. Let's take one of those higher low points. Let's do the easy one, this high point. Okay, so cosine of 0 radians. What is cosine of 0 radians? What is the answer? What is cosine of 0 radians? 1. Secant is 1 because you flip. What's 1 times 3 plus 2? What's 1 times 3 plus 2? 5. This is still a shared point. So that's what I was trying to prove. Some people try to flip 5 and put like 1/5, something crazy like that. Order of operations say these are all shared points for both secant and cosecant because of order of operations. With that being said, you can guarantee yourself, I missed an asymptote. You can guarantee yourself all you have to do is this: yoink, shared point flip, shared point flip, shared point flip, and so on and so on and so forth. So again, to graph secant, you graph cosine and do one more thing. All it is. It is so easy. All right. So the equation of the asymptotes. I have to ask the crew how we're going to ask it. I don't care. I'm grading your tests. I'm probably just going to tell you to do it as equation of asymptotes in this spot because mathematically these are two different things. So if AP is asking this way, I really don't like it. Sorry, AP. Some things are just a little off. And then the range. Okay, so now we got to really be careful on this range. We are going from negative infinity, but then the high value, I can't like ask you. You got to figure this out at this point. You should know how to find range from a picture. You know, it goes all the way down here, then stops here. Then we have this big gap here, no y values covered. And then it jumps up to 5 off into infinity with those arrows. All right. I mean, I think this should almost be enough. I'll probably do. How many more do we have on this page? Maybe 2 more, and then I'll do. I ain't doing that one, and then we can maybe look at these. I'll have you try to answer those, and then reveal the answer. So let's get going. We like this this coordinate plane better. This means usually 2 cycles. Probably a little bit too large. I was making the test. And I'm like, these are a little bit too many boxes, so I kind of shorten it up and send it out there. We'll see if they like what I sent or change it all. So I don't know. With this many boxes, I'm going to cut this in half. It is nice, but I just think sometimes too much. Then maybe I'll just go by threes. 1, 2, 3. And we usually need 1, 2. So we have 0, 1, 2, 3, 1, 2, 3. It's usually 4 values to the left and 4 values to the right. 2. So I guess it's not that bad. You really get nice spacing here. Get to work your stuff here. Okay, what's the period? I yelled at you yesterday. You yell at us every day. Is it 2 pi over 2 or is it 2 pi over a half? Which one is it? 1/2. What kills me is when it's like this, which is equivalent. That doesn't say 2x. This is what kills me when people put 2 pi over 2. If it said 2x, it'd be 2 pi over 2. So that's not 2 pi over 2. That is also 2 pi over a half. And then that doesn't become 1. That's if it was 2 pi over 2. What does this become? 4 pi. You get really bad stuff about this. Not really thinking. We got to do a little bit more thinking. And then there is no up, down, right, left shift, so we're good. There is no amplitude. We'll do the range after we do the graph. Okay, so instead of, we might go by twos on this one so we could get half values. Why not? This is what we have with all these extra boxes. We can really spread this out. So we can put this as 2 there, and then how does cosine start? High or in the middle? It's one or the other. Which one is it? Which one is it? High or in the middle? High. So it's high, 0, low. I just realized I didn't do something. 0, high. Okay, and that's what we have. What I didn't do though was the period stuff. Oh, this is so easy. What's half of 4 pi? What's half of 4 pi? What's half of 2 pi? 1 pi, 2 pi, say it. Well, that was hard. Okay, not negative 4 pi, negative 3 pi. That's the best one ever. Okay, and then I could go 0, low point. So I shouldn't besmirch this coordinate plane. I didn't really do it, but maybe make choices. If you have so many boxes, use them. Just get this all spread out and nice looking. So I guess it does work out pretty nice. All right, so I went too high. I did a double check on my equation that I didn't miss anything. I'm good to go. We're only going to do one more graph. I wish I could pause the video and have you look at those multiple choice and then just share the answer. All right, where there is zeros, there are asymptotes. Where there are, sorry, bad English. Okay. It was a good group back in the 80s. Nobody knows that one. Let me change colors, really make this stick out. Notice everything is dotted until I do the final graph. Oh. Does anyone come in by Reed Road, which is over on this side of the school over there? Yes? No? Oh, I did that. Did you, when you came in, is that when you got in? Because it was like I was backed up 20 cars at that stop sign. I was coming from I-80, from, I don't know all the other roads, but it's just such a pain getting into the school sometimes. All right, and then wrong. Infinity never has a bracket, or negative infinity. Negative infinity to negative 2. 2 to infinity, no up down shifts. And then, I don't know, just equation of the asymptote. X equals, we're at pi plus 2 pi n NEZ. Good to go? It's only easy if you know your previous stuff. Boy, that's what this whole class is about. All right? Just like the unit circle stuff. I thought I heard my door. Finally, a cosecant, and we're not shifting right left today. And by the way, I think we're kind of done. Today's Thursday, and our quiz is next week Thursday. I mean, I have two more things probably tomorrow and Monday, but they're going to be very review-ish, and then review and review. So we're going to be fine. We should be. Should be. I always have high hopes. High hopes. Okay. All right. So just kind of cut it up there. And then I don't have a right left shift. So I'm going to do the same thing I did before. Hey, 1, 2, 1, 2, 3. I got to make sure 1, 2, 3. I have the space, so I'll use it. 1, 2, 3. A little sloppy on that axis there. X axis. 2, 1, 3. 1, 2, 3. All right. Okay, what's the period? I think this one you can get. Oh, I love these. I love my fractions. Okay, so the period's 2 pi over 3. The one thing we did discuss, it is nice to graph it from 2 pi to negative 2 pi to see the difference between these two graphs. Do you know where 2 pi over 3 is? 2 pi over 3 is 1 pi over 3, 2 pi over 3. Look at, here's where 2 pi over 3 lands. If I were to graph this next graph compared to this one complete set of, U's and U's would fit in between there. It looks so cute. All right, it really would. All right, compared to this big gargantuan 0 to 4 pi one. All right, so I do want you to know that. Anyway, oh, and then what happens to it if I make this plus and negative? It gets what? What happens with it? X-axis reflection. Let's do the math words. X-axis reflection. Dilation by vertically by 2. We were talking about that. They don't say stretch rink. When you say vertically by 2, that means a number greater than 1. That means a stretch. All right. It's not an amplitude though. And then 1 up, right? We'll get that all in there when we do our points, when we think about sine. And then we'll do all that stuff after over there. Okay, so here we go. 2 pi over 3, the stuff to the right. Hey, everyone, what's half of 2 pi over 3? What's half of 2 pi over 3? pi over 3. The 2's cancel. Always hurts me when people say 2 pi over 6 and write that answer down. Guess AP wouldn't care, but what's half of pi over 3? See, you're getting it. All you had to do all year long was multiply the denominator by 2. 1 pi over 6, 2 pi over 6, say it. 1 pi over 6, 2 pi over 6, say it. 3 pi over 6, which is already reduced over there by Jake from State Farm. Hey, you made the video. 2 pi over 3, negative pi over 2, negative pi over 3, and negative pi over 6. All right, now this is where we got to be careful. How does sine start? That's what you also have to understand too. I got to graph sine. How does a sine start? Middle, top, or bottom? High, middle, low. Where does it start? What is the middle though? What is the middle? 1. We'll go by 2's again. I think that should be all right. This is right here. So 1, 2, 3. We'll go by 2's again just because we have the space. Okay, so we start in the middle. Oh, this is what we should do as well. Dun, 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 dun. Don't do that in the test, that noise when you're doing dotted lines. All right, and then this starts in the middle. And then what happens? High, middle, or low on pi over 6? I used to ask students, I used to make them answer questions. All right, little Johnny, what's f of pi over 6? What is the answer? And I give them choices. Is it 3, 1, or negative 1, I believe? Which one is it? 3, 1, or negative 1? Negative 1. Why? Why? Fluh, 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 fluh. Okay, so what? I killed pi over 6 there. All right. Then I said, hey, okay, what's f of pi over 3? 1. What's f of pi over 2? 3. What's f of 2 pi over 3? 1. And then careful on this one. Some people do this and then go back down. Nope. Now this is the high, middle. I'm trying to make sure. That's going to be on it. And then back to middle. Okay, that's for sine. For cosecant, I'm not even going to draw this. I know where the asymptotes are. I know I just have shared dots. Okay, so I'm going to draw the asymptotes. I don't even need the graph. The sine curve. I was trying to make sure I was saying sine there, not cosine. And then the shared dots is where we flip stuff. Sometimes this happens. Just get that little part there, a little bit high there on this. This one's better. I got more space to graph this one. A little bit high there. We just get a little bit of a U in there, and then a little bit low. That's the graphs we like. We like having the 4 x values noted, and that's what you need to do. Okay, now I can do the asymptotes. X equals 0, 0, and then they're pi over 3 away, half of the period. Yeah, I said 3. 2 came out of my brain. And then the range, of course, is from negative infinity to negative 2. Wrong. I had the up one. And then union that with 3 to infinity. That's essentially the notes. I'm not doing that one. It's enough. A, B, I'll write the equation for. I should do that one. Okay, sorry. I shouldn't skip over that. We like these. As a matter of fact, we're making the test. We got a lot of questions with here's the equation, and then what's the information. Then we have here's the picture, what's the equation, and then you have 4 choices. So something that you need to be able to figure out. Okay, so try A and B real quick. Write 822, and then I think we're going to do a mad scramble for homework stamping. Been really bad at that. Sometimes I'm bad perennially when it's getting close to spring break. Somehow I just stop my stamping thing. Then I'll be refreshed after spring break. We'll be stamping like crazy, hopefully daily. Got a little pie bracelet here too. I forgot who I got this from. Just stalling right now. Okay, hopefully you can see that -1 and 1. They're hiding in there. See that? I was like, wait, what are those numbers for the high-low points? You can fast forward this part of the video. I can't pause. I don't know if I could in Screencastify. I think I could. Lost so many features by losing Screencastify. Sorry, WeVideo, you're killing me. Lost a video yesterday. It's like 5 videos I lost this year, just off in the spinning circle world. Are you listening? Hey, what's this first graph? A secant or a cosecant? Which one is it? Letter A. It's secant. If you can't, you don't figure that out. I mean, you have a cosine kid, all right? So that's if I draw this, this is what I would do in order to do this. Oh, okay. Hey, how much of a cosine kid do I have when I draw this? How much of it? Give me a fraction. What fraction of a cosine kid do I have? Half. So where does this actually end? 1 pi over 8, 2 pi over 8. Anyone? Well, that's the next one, 3 pi over 8, but where does it end? 1 pi over 8, 2 pi over 8, 3 pi over 8. What's next? 4 pi over 8, which is what? So the period is actually pi over 2. So it's a secant graph with a period that equals pi over 2. So period equals 2 pi over b. The period is pi over 2. What do I do with the b and the pi over 2? Anyone? Switch. And then the whole idea of doing this, or you might be able to figure it out, 2 pi over what is pi over 2? That's also, should be something that we're able to do. Cancel, then 2 over a half is 4. All right, and then my a value, this is right side up, so our a value is still 1, and it's positive, and then 1 secant 4x. How many people got that all by their lonesome? Nice. Okay, what do we see on the next one? A secant or a cosecant? What do we see? It's a secant, or I'm sorry, cosecant. You said it. Because it starts with an asymptote. So right away when you see that. By the way, we could call it a shifted cosecant, but again, there's an infinite amount of answers for this. And then what's A? I didn't say amplitude, but what's A? What is A still? What is A? It's still 1 because it goes 1 up and 1 down. But what we do have is a dotted line. Okay, so that's what we have. We have this little situation here. And then what's the period? What's the period? I just circled it. 2 pi. So the only thing that's happening on this is it's y equals. It is 1 because it's 1 up, 1 down. It is a cosecant because of where it starts. It is a 1x. You don't have to write the 1, but I just want you to know 2 pi over 1 is 2 pi, so b is 1. But then it is down 2. All right, so that ain't that hard. Okay? All right. You can get these. I want to get stamping here. I don't know. Try to do the best you can on that. What's the equation of the vertical asymptote? Secant is the period is 2 pi over 2, which is pi. I guess I'll just shove these answers at you. But for secant, the period is cut in fours, and our first asymptote is 1/4 of the period, if you've noticed that. So 1/4 of the period is pi over 4. That's the problem with this. For cosecant, the first asymptote, that's x equals 0, and then the next one is 1/2 of the period, which I thought is a vertical asymptote for g. Okay, 2 pi over pi means 2 is the period, all right? But this is a cosecant, so that means our vertical asymptotes are at x equals 0, x equals 1, x equals 2. It's half the period, each block. So when I look at this, the one that hits is x equals 1. Which of the following gives the range? All I have to look at this to understand the range. It's not up or down. I don't really care about the period. So wait a minute. For cosecant, sine goes from 3 to -3. Cosecant does the opposite. It's negative infinity to negative 3, and then 3 to infinity. Okay? All right, so I figured that. Get your homework. All right? I want to stamp like a fool here. I got to get something done. I'm hitting the wrong things.